So in this part we're going to look at sequences. Now, a sequence is a finite or infinite list of terms or numbers, usually numbers actually in mathematics, arranged in a definite order. That is, there is a rule by which each term may be found after the previous one. So there's a rule by which each term after the first may be found. So first two very simple examples, 1, 2, 3, 4, 5, straightforward enough. And the second example, 1, 4, 9, 16, 25. If you notice that those are the squares of 1, 2, 3, 4, 5, and 6, you might quickly spot that the next number necessarily is 36, 6 squared. Now, notice the dot 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 at the end of the sequences. This infers that the sequences continues on ad infinitum, indefinitely. These dots, just as a quick remark, are called ellipses. There's a name for those little dots. So just you can just sort of say and so on. Now, more precisely, a sequence is actually a function where of the domain are natural numbers and the codomain is real numbers, and so on. And in this first example, we had the f of n. The rule was the nth term of the sequence was just n. For every n in that is a natural number. The second example, we had f of n equals n squared for each natural number. The nth term in the sequence is f of n, where f is the function defining the sequence, but we're going to call this a from now on, a subscript n. I'm going to say a of n. So correctly it is a function, but the convention is to use a of n, so just write it up again up here, to denote the nth term of a sequence. So in the previous examples, a1 was 1, a2 was 2, a3 and so on. And in the second example, a1 was 1, a2 was 4, and a3 is 9, and so on. Now you can write a function. You can write a sequence in terms of the component terms a1, a2, a3, a4, and so on. The shorthand we would use for this is the set of numbers a of n from n equals 1 to infinity. Okay. Just as a remark, depending on the context, sometimes it's useful to start at n equals 0. Okay. Now, most of the time I would be starting from n equals 1, but in some occasions it would be appropriate to start from n equals 0 and then 1, 2, 3. Now, using this notation, the rule for obtaining each term is defined by the nth term. So list the first four terms of the following sequence. an equals n squared plus 1. I'll just quickly do the first one here. And again, we're going to assume that the first value is 1, starting from n equal 1. So 1 squared plus 1, that gives us 2. 2 squared plus 1, that gives us 5, and so on. So again, they're written out down here at the bottom. a1 is 1 squared plus 1, and that's equal to 2. a2 is 2 squared plus 2, 2 squared plus 1, that's equal to 5. a3 is 3 squared plus 1, 9 plus 1, that's equal to 10, and so on.